Now the other way to combine function is using composition. So remember, composition is given by a circle, and f circle g of x means f of g of x. So you take the function g and you put it inside the function f in place of x. And your domain here, well, x has to work in g so that your g is defined, and then g of x has to work in f. So it involves domains of both of the functions. So we'll concentrate on that here in a second. So we take our same functions that we had in the previous example. Let's find f of g of x. So f circle g of x is f plug in g of x. And so our inside function g of x is the root 1 minus absolute x. So we're taking f. We are plugging in that root 1 minus absolute x. And then I like to take our function f, our outside function, write it with empty parentheses in place of x. So 1 over 1 minus parentheses. And then what we're putting inside the parentheses is this whole function, root 1 minus absolute x. So let's look at domain for this one. So domain of f circle g. Well, the x has to work inside of g, so your 1 minus absolute x here, that has to be greater than equal 0. So we need the 1 minus absolute x has to be greater than or equal to 0. But then also this whole denominator cannot equal to 0. So we need that, and we need that 1 minus that quantity root 1 minus absolute x. We can't have that equal to 0. So let's see. So I want to say here that so we need this and not denominator equals 0. So this one we already saw up above. That was x between 1 and negative 1. So this was x is an element of closed interval negative 1 to 1. So I need that to happen. But then we also want to find the x value that makes this happen. So let's bring that square root over on the right hand side. So 1 equals root 1 minus absolute x. We square both sides, get rid of that square root. So we get 1 equals 1 minus absolute x. We can cancel the 1's off both sides. So we get 0 equals negative of absolute x. We can multiply both sides by negative 1. So we get absolute x equals 0, which means x equals 0. So we can't have x equals 0. So inside this interval, but not x equals 0. So our domain of f circle g is going to be negative 1 up to 0, union 0 to 1. So we kept everything in here, but we kicked out 0. So it's a little bit more work finding domain for composition, but that's the process you go through. What about g circle f at x? So g plug in f of x. So now we've got the function g. We're plugging in f of x, which is 1 over 1 minus x. Now what's g do to what you plug in? Well, it does square root of 1 minus and then absolute value. And what goes inside the absolute value, so that's acting like our empty parentheses, it's 1 over 1 minus x. So there's that composition. And we can find domain the same way that we did up here, making sure x works in here, and then the 1 over 1 minus x has to work in the bigger function. How about f circle f of x? So that's f plug in f of x. So you do composition of a function with itself. So this is f plug in our inside function f of x, 1 over 1 minus x. Now write your outside function with empty parentheses. So that's 1 over 1 minus parentheses. And what are we putting in parentheses? This whole thing, 1 over 1 minus x. So there's our composition. And then we've got a couple compositions at specific values. So g circle f at 2 is g of f at 2. So here, work from the inside out. So your f at 2 is plug 2 in here. So it's 1 over 1 minus 2, which is 1 over negative 1, which is negative 1. So this is really g plug in negative 1. And then we're plugging that negative 1 in here. So this would be root 1 minus absolute value of negative 1, which is absolute value of negative 1 is 1. So that's 1 minus 1 under the square root. That's root 0, which is 0. And then g circle f at 0 here. So f of g of 0. So again, take 0, plug into g first here. So g plug in 0 is square root 1 minus absolute value of 0. Well, that's just 0. So this is just square root of 1, which is 1. So this is really f plug in 1. And now for f, you plug your 1 in here. So 1 over 1 minus 1. But that's 1 over 0, and that's undefined. Can't divide by 0, right? So what that means is that the number 0 is not in the domain of f circle g. Okay, and we saw that up here. Domain f circle g here, 0 was kicked out, right? We cannot have x equals 0. That's why.